Yes, sir. In the last class, we discussed few problems by using the properties of determinants. Okay, that too, 2 marks questions, and it has been given that without actual expansion, that means you need to use the properties of determinants and we need to solve. So in the last class we have solved up to few problems, then we continue that of the 2 marks question. So this question is the 5th question. This is 5th question with the 2 marks. See, if you look into this again you need to show it is equal to 0. To show it is equal to 0, what we need to do is, we need to make any 2 rows or 2 columns identical, or you need to show any one of the row having all the elements equal to 0. That is the only possibility to show according to the property what I have given. See, if you look into this 100 into 100 and 300. So 300 is 3 times of 100. 300 is what? 3 times of 100. 156 you see, it is 3 times of 52. If 81 is see, it is 3 times of 81. So that means, okay, I can write 243 as 3 into 81, 156 as 3 into 52, and 300 as 3 into 100. In the next step, what I can take is 3, if I take common, if I take 3 common, I'll get 81 as well as 81. 52, 100, 100. So thereby what happens? These 2 rows will become identical. If you want, you can divide by 3 if you want. Otherwise, you can go with the multiplication. So next step. In this step, what I can write is, I will write 243 as 3 into 81. Next, 3 into 52 for 156. 3 into 100 for 300, right? Now this is 81, 52, 100. Minus 3, 0, 4. So in the first row, I can take 3 common. When I take 3 common, I will get 81, 52, 100. I will get second row, 81, 52, 100. So that is minus 3, 0, 4. Very clearly, these 2 rows are identical. Very clearly, first and second row are identical. Okay, here, so 2 rows are identical. Therefore, determinant is 0. So therefore 3 into 0 will become 0. 3 into 0 will be 0. Hence it is true. Yes, you can copy down the 5th question. The next problem is 7th problem I have taken. That means 6th problem will be homework for you. So 7th problem, it has been given the determinant in the form of a numbers, and that determinant you need to show it as 0. That means you need to make any 2 rows identical, or any 2 columns identical, or you can make any 1 row or any 1 column as the elements equal to 0. I hope we can do it. Yes. I will write second row changes to second row minus first row. Similarly, third row changes to third row minus first row. Right? Both you need to do because we have 3. So 10, 11, 12. What I have done? Second row has to change. What is second row? 13. Okay. 14. As well as 15. How I need to change second row? By subtracting the element of the first row. Minus 10. minus 11 minus 12. Similarly, third row also 16 minus 10, 17 minus 11, 18 minus 2. So this will become 10, 11, 12. So here what happens? 13 minus 10, 3. 14 minus 11, 3. 15 minus 12, 3. Similarly, 16 minus 10, 6. 17 minus 11, 6. Here it is again 6. Okay, in the first row there is no possibility of taking anything common. In the second row I can take 3 common. In the third row I can take 6 common. So in the second row I will take 3 common. Okay, then I will take 6 common. In the third row I have taken both common, 10, 11, 12. So we know that 3 can be written as 3 into 1. 1, 1, 1, 1, 1, 1. According to the property what? 2 rows are identical, so therefore determinant is 0. Hence 3 into 6 is how much? 18 into 0, or you can write 3 into 6 into 0, which is equal to what? 0. That is equal to 0. Hence it is being proved. Please copy down this one. Yes, sir. The next is the 8th question. It is the 8th question. I need to show again this is 0. So you can consider first row and third row. You subtract first row with third row or third row with the first row. I will change third row. Third row changes to third row and take plus first row. Right? So I need to prove it is equal to what? That is equal to 0. I need to prove it is equal to 0. I am changing third row. That means I am not changing first row. X plus y, y plus z, z plus x. X, y, z. How I am changing third row? X minus y plus r1, x plus y. Next, y minus z plus z, y plus z. Next, z minus x plus x plus z. Now this will become x plus y, okay, x plus y, y plus z, z plus x. So x, y, z. So this will give you what? X minus y plus x plus z. Okay, this one. This will give you z, y minus z plus z. Sorry, plus y minus plus y plus z. Next, z plus x plus z minus x. If I am not wrong, right? These are the things. Oh, reverse. This is minus and this will become plus, right? X minus y plus, right? Then that is also right. This is also right. So I will get x plus y x. I will get 2x. I will get 2x. Y plus z y. I will get 2y. Then I will get z plus x, z, 2z. I hope in the third row I can take 2 common. In the third row I can take 2 common. Here what happens? X plus y, y plus z, z plus x. X, y, z, x, y, z. Very clearly what happened? two rows are identical. Two rows are identical. So therefore determinant is 0. Hence 2 into 0 is equal to 0. 2 into 0 is equal to 0. Hence proved. Yes, sir. I have taken 10th question. 10th and the 9th both one and same only. For 9th we have positive sign here. Okay, and the proof is also same. For the 10th, instead of positive sign, we have negative sign. Minus A as well as minus B. Minus A, 1 minus B. We told that you need to show that the given determinant is equal to 0. I have given only two properties. According to the property, so far what we have solved. According to the property, so far what we have solved, we made two rows identical, or we have made two columns identical, or we made any one row, any column identical. Why? Because if we do so that, if we make two rows or any two columns identical, then the determinant value will be 0. Similarly, if I make any one row or any one column, all the elements 0, then the determinant will become 0. But here we are not supposed to prove it is equal to 0. We need to prove it is A into B. That means we need to apply the third property. What does the third property tells? Okay. In the principal diagonal, this is principal diagonal. Either the lower elements or the upper elements should be 0. Then only you can multiply the principal diagonal. So here what happened? No, our intention is we need to make this. If this is the principal diagonal, we need to make all this 1 as 0 or all this 1 as 0 or both. But any one triangular shape. Okay, that means the elements which are present below the principal diagonal or above the principal diagonal, that region has to be elements equal to 0. So for that, what we will do is, okay, what I will do is, I will change R2 changes to R2 minus R1, so that this I will get 0. R3 changes to R3 minus R1. If I change, this will be 0, this will be 0, our problem will become very easy. So 1, okay, I will write this side, 1, 1, 1, because we didn't speak anything about the first row. We are speaking, or we are supposed to change only the second and third row. What is the second row? 1. 1 minus A, 1. Second row. That second row, what I need to do? I need to subtract with the row of the first element, minus 1. Minus 1, minus 1. Similarly, third row, 1 minus 1, because third row with first row, 1 minus 1, 1 minus 1, 1 minus B, minus 1, 1 minus B, minus B, minus 1. Now very clearly what happened? 1, 1, 1, 1 minus 1, 0, minus 1 plus 1 will get cancelled, will get minus A, this also will be 0. 0, 0, this I will get minus B. Very clearly we have, okay, the principal diagonal, lower elements of a principal diagonal are equal to 0, therefore, okay, therefore what we need to do is, multiply, therefore product of principal diagonal elements are 1 into minus a into minus b. That is nothing but ab, because minus into minus plus, 1 into a is a into b is ab. Hence it is proved. Similarly, 10th problem. Okay, that's it. In 10th problem, what happens? No, we will not get minus a minus b, we will get ab. Okay, so same steps, except here we will not get minus a minus b, we will get only ab. Remaining all are same. So thereby, in exercise 1.4, 2 marks questions are over. In the next class, we will take 3 marks questions, which are very, very important one. Yes, thank you very much.